After we've marked off our site and done our site sketch, we will proceed to the habitat survey. This video is to show you how to do a RiverWatch habitat survey. As you look at your habitat survey sheet, there's a list of parameters. We'll go through them in order, starting with present weather. If you notice, beside present weather on your sheet, there is a page number in parentheses. In fact, there's a page number by all the parameters on the sheet. That is the page number that has the information that you can look up in your manual for exact instructions how to do it. So always remember you can refer to that page number in your manual. Our first parameter is present weather. Today, if we look up at the sky, we can see that it is clear and sunny. It may look dark in here, but that's just from the shade cover. So we would mark clear and sunny. The other options are overcast, showers, rain, and storm. Please do not, if you have to check storm on your sheet, you probably shouldn't be in your site. Do not monitor in heavy rain or storm. The next parameter is worst weather in the past 48 hours. It's important to know if we've got a large rain event in the past couple of days. If you have high flows and flooding, that's not only dangerous from you, but it can also sweep away some of the macroinvertebrates that you're looking to catch. So you want to let a stream stabilize after a large rain event. So mark down the worst weather in the past 48 hours. We've mostly had clear and sunny here the past couple of days, so we'd mark clear and sunny also, so this is a good time to monitor. Your other options are similar to the first one: overcast, showers, rain, or storm. So mark your worst weather in the past 2 days. Next parameter is temperature. We will take the air temperature and the water temperature. It's important to take the air temperature first, because if you take the water temperature first, water could evaporate off the tube, off your alcohol thermometer that we have in all the RiverWatch kits, and cool it off. So we want to take air temperature first. You want to hold it near the top so you're not warming the thermometer near the bottom, and you would let it stabilize. About 2 minutes is a safe bet to let it stabilize. It's already been sitting out here though for longer than that, so we're going to go ahead and read it. Our data sheets have Fahrenheit and Celsius, so make sure you either circle the F or the C depending on which side of the thermometer you read. We'll go ahead and mark Celsius today. We're at 25 degrees Celsius, so we'd mark that on a data sheet for air temperature. It's a hot one today. And then we would want to get our water temperature. Now for water temperature, it's good to stand in a shaded part of the water if possible. The sunlight can heat up shallow water very quickly, so you don't want to get that variable in there. Hold it near the top. You want to stick it in the water, a few inches down, but not on the bottom of the water. You don't want to stick it in the on the bottom of the stream. You want to have it just off the bottom, a few inches under the water. You would hold it there for a couple of minutes to let it stabilize from the air temperature to the water temperature. Water temperature is one of the most important factors for determining what the macroinvertebrates are doing. It really influences their life cycles when they hatch, when they pupate or metamorphose into adults. If you monitor earlier in the year, really early in the year, and you've had a cold winter, you could have a really cold water temperature still, and that could lead to not as many macroinvertebrates. All right, we're going to go ahead and read our thermometer. We've dropped down to about 20 degrees Celsius. So the water temperature here is still pretty warm, but it's cooler than the air temperature. So we would mark 20 degrees Celsius on our page. The next parameter is water appearance. This is the color of the water. We're going to have Allison here scoop some water in her tray. Notice she's doing it upstream. You don't want to have it downstream of you where some of the dirt that you're stirring up could get in it. She's going to set the tray on the ground. Just have an inch or two of water in it. And this is just a visual inspection. You just look at the color of the water and make your best judgment according to the options you have. Clear, milky, foamy, dark brown, oily sheen, reddish, green, or other. Obviously today our water is clear, so we would mark clear on our sheet. The next parameter we have is water odor. This is the smell of the water. We have several options. It could be none, that's probably the most common one. Sewage, chlorine, fishy, rotten eggs, petroleum, or other. Please note that if you ever smell a strong sewage smell, it's probably not a good idea to go in the water. This can sometimes happen after large rain events if the sewage system gets overflow into your creek. You don't want to get into the stream. So to do this, all you have to do is grab your water appearance sample, hold it up near your face, and just smell it. If you get close enough, if there's any smell, you should be able to detect it. So no smell in this water. So we've got clear water and no smell today. Our next parameter is turbidity. Turbidity is a word that measures how many of the particles suspended in the water. So we measured water appearance earlier, which is kind of like the color of the water. Now we're going to look at the how much particles are suspended in the water. To do this, we take this white tray that we just used for our water appearance. You can pour the water out of it. Now I'm going to have Allison hold it, just pin it to the bottom of the stream, just upstream of you. Let the water flow over it. All right, you can see Allison has it pinned to the bottom and she's watching the water flow over it. This will allow you to see how much particles are suspended in the water. Our options are clear, slight, medium, or heavy. Heavy amounts of turbidity. And today, as you can see, our water is clear. So there's not many particles suspended in the water. So you can go ahead and take that out of the stream, Allison. Thank you. Turbidity is very important to measure. If you have a lot of turbidity in the water, say like the Illinois River or even some parts of the Mississippi, it blocks out sunlight that goes down towards the bottom of the stream. It can fuel primary production like photosynthesis. And lots of turbidity can also be evidence of erosion, the silt washing away and washing into your stream. So it could be evidence of that, so things to look out for. So we've got those first 6 parameters in the first box. We've got those filled out. We've got a couple more boxes on that habitat survey sheet. So now we are going to do, we're going to move into canopy cover. This is the shading of your stream. You want to mark the canopy cover that's present while you're there in the stream. If you monitor earlier in the year and the trees are not fully leafed out, don't mark it as if they would be in summer. Mark it at whatever time you are in the stream. So our options are, on your sheet you'll see 0, 1 to 5%, 6 to 25, 26 to 50, 51 to 75, and 76 to 100. So those are your options. But we also, for this parameter, we want to measure canopy cover for the whole site, all 200 feet. And it's really hard standing in one spot to know the canopy cover for your whole stream. So for RiverWatch, we walk our whole stream and we take an estimate for each section. Now you want to estimate a specific number. Don't estimate 26 to 50 for one section. Go ahead and estimate, say, for here, it's very shaded, we would estimate about 90% shading. So we would write a little 90 by canopy cover. We would estimate it for 4 sections of the stream, every 50-foot section. So for this 50-foot section, we would just kind of jot down a 90, and then we would walk to the other sections of our stream and estimate the canopy coverage for each section there. Say if we had 90, 70, and 60, and then maybe another 90, we would round that up, and that would be in the 80% range. And so we would mark 76 to 100% shading. That ensures that you get a representative sample of all 200 feet of your stream site. And that is for canopy cover. Now for algal growth, substrate siltation coverage, and bottom substrate, which we'll do in a little bit, these are all percentage estimates. This is what you observe. It's not an exact measurement, it's your estimate. And so you'll do the same thing for all these parameters. You'll start at the bottom of your site and walk upstream and estimate it for each 50-foot section. So our next one is algal growth. This is another percentage estimate, so we do it 4 times. What you would do is you can kind of get down in your stream. You're looking for the green fuzzy stuff on the rocks or kind of floating in the water. We're looking for filamentous algae. Sometimes it looks like green hairy stuff. As you can see in this stream, if we look around a little bit, there is not much algae at all, at least none that I can see. And so for this 50-foot section, we would estimate 0%. So we would jot a little 0 down by algal coverage. We would walk to the next 3 sections of the stream, the other 50-foot sections, and estimate algal growth there. We would jot all those numbers down, average them together, and mark our box on algal growth. Either 0, 1 to 5, 6 to 25, and so on, %. You don't have to do your averages in the field. As long as you have those numbers jotted down, you can take it back to your house and get comfortable and do some math.